There is an iron chest in the heart of El Escorial that Philip II ordered to be locked in the year 1577, and which was not opened again until fire destroyed it forever 94 years later. Inside that chest was something no European king possessed and no power on the continent yet understood. The most complete catalogue of the living medicines of the New World, compiled over 7 years of fieldwork by the most important physician the Spanish crown had ever sent across the Atlantic. 16 handwritten volumes, more than 3,000 catalogued plants, botanical illustrations executed with a precision that would not be seen again in the Americas for another 2 centuries. Testimonies from Nahua healers and physicians who had taken millennia to learn what they knew. Dosages, preparations, diagnoses, symptoms, Nahuatl names transliterated with phonetic care by a man who understood that language and plant were inseparable. Philip II received it all. He kept it, and he silenced it. What happened next is a story that blends 16th century geopolitics with the fire of a June night, the clumsiness of a hasty friar, and the quiet obstinacy of a few men who refused to let knowledge die completely. But before we arrive at the silence, we must understand what was being silenced. We must understand who Francisco Hernández was, what he found, with whom he found it, and why what he brought back to Madrid represented a threat great enough for a shrewd and meticulous king to decide to hide it from his own time. Because that is the question this story has been waiting 4 centuries for someone to ask aloud. What was in those 16 volumes that Philip II didn't want anyone else to read? Francisco Hernández de Toledo was born around 1515 in La Puebla de Montalbán, a town in Toledo that at the time was one of the centers of Spanish intellectual life. He studied medicine in Alcalá de Henares, the university that Cisneros had founded as a humanist project, and which, in those years, was the place where European medicine engaged with the Arabic texts that had arrived through the Toledo School of Translators. Hernández was familiar with Galen and Avicenna. He knew the canon of medicine and the Dioscorides that Andrés Laguna had translated and commented on in 1555, that monumental book in which the Spanish physician had attempted to reconcile classical Greek botany with the plants arriving from the New World that had no names in any European language. Hernández was, in the best sense of the word, a Renaissance man. Curious, methodical, able to read in several languages, trained in direct observation rather than deference to authority. He had worked as a doctor in Toledo, Seville, and the mines of Guadalcanal. He had studied the nature of climate and its effects on health. And when, in 1570, Philip II summoned him to Madrid to entrust him with the first official scientific expedition to the New World, Hernández was 55 years old and had spent decades preparing for exactly this without even knowing it. The royal instructions were precise. Hernández was to travel to New Spain, explore its natural resources, catalog its medicinal plants, record their uses among the indigenous peoples, and bring back a comprehensive report to the crown. Philip II was a sick man. He suffered from gout, arthritis, and a host of chronic ailments that made the search for new remedies almost a personal matter. But the royal instructions also had a strategic dimension that went beyond the monarch's health. Spain possessed an entire continent coveted by other European powers, and part of that continent was a pharmacy. To know it meant possessing it in a way that no navy could replicate. Hernández arrived in New Spain in 1571. From the very first moment, he did something that no European scientist had ever done before with such systematicity. He sought out local doctors and sat down to learn from them. The Mexican medical system was not shamanic improvisation. It was an elaborate structure with distinct specialists, reference texts, medicinal plant markets, and hospitals. The ticitl, as the physicians were called in Nahuatl, had developed over centuries an empirical pharmacological knowledge that included plant classifications by properties, dosages differentiated by age and patient condition, and a detailed understanding of active principles, though not with the chemical vocabulary that would not exist until 2 centuries later. In the great market of Tlatelolco, which the conquistadors had described with awe in the early colonial years, there was an entire section dedicated to medicinal plants, with vendors specializing in specific illnesses. That market no longer existed when Hernández arrived. 50 years had passed since the fall of Tenochtitlan, but the knowledge that sustained that market still lived on in the fields and courtyards and in the memories of the survivors. Hernández established his base of operations at the Royal Hospital of the Natives in Mexico City. It was the hospital the Crown had founded to care for the indigenous population, and within this clinical context, the Spanish physician began working with a group of Nahua doctors whose names history has only partially preserved. Martín de la Cruz and Juan Badiano had produced 20 years earlier what we know today as the Cruz-Badiano Codex, the first American medical treatise written in Latin, which had arrived in Europe in 1552 as a gift from Francisco de Mendoza to King Charles I. Hernández was familiar with this text. He knew that a system existed, not just a collection of isolated practices. For 7 years, Hernández traveled the length and breadth of New Spain. He visited the markets of Tenochtitlan, Texcoco, Tlaxcala, and Cholula. He climbed the Sierra de Tehuacan, where the botanical diversity was among the highest in the Americas. He explored the cloud forests of what is now Chiapas. He traveled along the Gulf and Pacific coasts. He reached the Northern Territories, which at that time were pure frontier exploration. And in every place, he asked questions. He listened. He took notes. The doctors and informants who collaborated with Hernández were not marginal assistants in the project. They were the architects of the knowledge he was transcribing. The Spanish doctor knew Nahuatl fluently enough to understand the names of the plants in their original language, and he understood that translating them into Latin without preserving the Nahuatl name was tantamount to losing information. This is why his manuscripts are extraordinarily rare documents. Texts where the Nahuatl name, morphological description, medicinal use, and illustration coexist in the same register, without any hierarchy between European and American knowledge. Imagine what that work in the fields meant. A 60-year-old man walking through the markets of Oaxaca with a notebook, stopping at each herbalist's stall to ask, "What does this do? How is it prepared? In what quantity? For what illness? In what season is it harvested? Which part of the plant? Is it taken raw or cooked? What else is it combined with?" And on the other side of the stall, a woman with decades of clinical experience who knows exactly the answers because that knowledge is part of her daily practice. That conversation, multiplied thousands of times, is the substance of the 16 volumes. The plants that Hernández cataloged were not just botanical curiosities. Many of them had medicinal uses that today, 5 centuries later, pharmacological science is validating in ways that would have astonished even Hernández himself. The chicolote, the plant botanists call Argemone mexicana, appears in Hernández's manuscripts as a treatment for eye diseases, and for the tertian fevers we now recognize as malaria. Research published in the last 30 years in specialized journals, such as the Journal of Ethnopharmacology, has identified alkaloids in this plant with confirmed activity against Plasmodium falciparum, the parasite responsible for the deadliest form of malaria. This is no coincidence. It is exactly what the ticitl people told Hernández, that it was useful for intermittent fevers. Capalchi, known to botanists as Hintonia latiflora, appears in manuscripts as a remedy for diabetes, although Hernández did not use that term, which did not exist in the medical vocabulary of the 16th century. He wrote about illnesses characterized by excessive thirst and frequent urination, an accurate description of hyperglycemia, and recorded that the ticitl people used the bark of this plant to regulate them. Clinical studies conducted in Germany and Mexico over the last 30 years have documented that Capalchi reduces blood glucose levels with an efficacy comparable to some modern hypoglycemic agents. Research carried out at the National Autonomous University of Mexico has identified the responsible compounds, coumarins with direct hypoglycemic activity. Tionanacetol, which Hernández described with remarkable caution, he was aware that it was a central element in religious ceremonies that the Church considered idolatry, appears in his manuscripts as a substance that produces visions, alters the perception of time, and can be used to diagnose illnesses in altered states of consciousness. The psilocybin mushrooms that Hernández catalogued under that name are now being investigated by leading academic institutions, Johns Hopkins University, Imperial College London, and the University of Basel, as treatments for treatment-resistant depression, post-traumatic stress disorder, and addiction to alcohol and tobacco. The results of clinical trials published in journals such as Nature Medicine and JAMA Psychiatry are so robust that the U.S. Food and Drug Administration has granted several of these compounds the designation of breakthrough therapy. Hernández saw them. He documented them. He described them with the rigor available in his time. And for 4 centuries, that documentation remained inaccessible because a king decided it should not be circulated. But it's not just these 3 plants. Hernández's 16 volumes covered more than 3,000 plant species, over 400 of which had clearly documented medicinal uses. They included plants that we now know contain alkaloids with anti-tumor activity, compounds with antibacterial properties, active against bacteria resistant to modern antibiotics, phytochemicals with anti-inflammatory activity comparable to non-steroidal anti-inflammatory drugs, and adaptogens that modulate the immune system with an efficacy that conventional pharmacology is taking decades to characterize. But the magnitude of what Hernández catalogued only acquires its true dimension when the system that sustained it is understood. The plants did not grow on their own, nor were they used in isolation. They existed within the context of an agriculture that had taken thousands of years to develop. The milpa system, the combination of corn, beans, and squash that the peoples of Mesoamerica had perfected over 3 millennia, was not just a farming method. It was a system of food security, soil management, pest control, family economy, and preventive medicine, all integrated into a single productive unit. When Hernández traveled through the fields of Tlaxcala or Oaxaca, he saw milpas where, among the edible plants, grew epazote, a natural antiparasitic whose active ingredient, ascaridol, was isolated by modern chemistry in the 20th century. Yerba santa, various qualites, edible wild greens, and plants whose leaves were used to wrap food and whose antimicrobial properties protected it during preparation and storage. The family gardens that Hernández visited during his travels through New Spain were surprisingly complex. A garden belonging to a Nahua farming family in the Puebla Valley could contain between 60 and 80 different plant species, each with overlapping functions that encompassed food, medicine, and ritual. This diversity was neither accidental nor a product of blind tradition. It was the result of multi-generational empirical observation of which plants coexisted well, which inhibited each other, which attracted pollinators, which repelled pests, which enhanced the flavor of others when cooked together, and which served to preserve food in the summer heat. Hernández understood that he was observing science. He didn't call it that because the modern concept of science didn't yet exist. Francis Bacon would publish his Novum Organum 40 years later, but the methodology he recognized in the ticitl and Nahua farmers was fundamentally empirical. Systematic observation, repeated tests, and refinement of hypotheses through accumulated clinical experience. What European physicians of his time called authority, references to Galen, Hippocrates, and Avicenna, was replaced here by direct observation and the controlled transmission of knowledge through generations of specialists. A passage from his manuscripts, preserved in the partial version published by the Jesuits in Mexico City in 1651, describes how Nahua informants corrected him when he tried to classify a plant based on European morphological criteria. They explained that the correct classification was functional. This plant is related to that one not because they have similar leaves, but because they have similar effects on the liver. It is, literally, a prefiguration of modern pharmacognosy, which classifies plants by their secondary metabolites and mechanisms of action, not by their external appearance. That conversation, between the doctor trained in Alcala and the ticitl trained in a tradition that had no written name in Spanish, produced something the world had not seen before. A real synthesis, not an imposition, not a reductionist translation, but a dialogue in which European knowledge and American knowledge questioned each other and enriched each other in the process. The 16 volumes that Hernández delivered to Philip II in 1577 were the result of that dialogue. They weighed, literally, more than any other scientific work produced by the Spanish crown up to that time. They contained more than 2,000 botanical illustrations, drawn mostly by Nahua artists whom Hernández had trained in the conventions of European scientific illustration, but who brought to his work the descriptive precision of those who had grown up looking at these plants all their lives. The combination was visually extraordinary. Plants drawn with European perspective and with American taxonomic detail, in a graphic language that no European botany book had been able to create from within. Hernández also described animals, minerals, agricultural traditions, food preparation techniques, irrigation systems, and the structures of plant markets. The 16 volumes were not a herbal in the classical European sense, a list of plants with their uses, but something far more ambitious, a comprehensive description of the natural and cultural system that sustained life in the New World, a portrait of a civilization through its relationship with nature. Philip II received them. He read them or had them read, and he made a decision that changed the history of medicine. He didn't publish them. In the spring of 1578, the king commissioned a Neapolitan physician named Nardo Antonio Recchi to prepare an abridged version. Not an edition, an abridged version. Recchi spent several years at El Escorial reviewing the 16 volumes and extracting what he considered most relevant, reducing Hernández's work to a fraction of its original length. Plants that Recchi deemed less important to European pharmaceutical interests simply disappeared. The cultural contexts that made the use of each plant understandable were eliminated as irrelevant. Nahuatl illustrations were replaced in some cases with more conventional versions that lost the taxonomic precision of the original. Recchi's abridged version, which was also not published immediately but circulated in manuscript copies for decades, was a shadow of the original work. Why didn't Philip II publish Hernández's manuscripts? Here the story becomes darker and more interesting. The simplest and most superficial explanation is that the complete 16-volume edition with over 2,000 illustrations would have cost a fortune that the printing press of the 16th century could hardly afford. The king had other financial priorities: the Spanish Armada, the Spanish tercios in Flanders, the religious wars that were draining the crown's treasury. An American botanical encyclopedia could wait. But that explanation isn't enough. Philip II wasn't a man who abandoned things out of lack of interest. He was the monarch who had built El Escorial, who had commissioned the royal pharmacy of El Escorial with the most complete collection of medicinal plants in Europe, who had founded the gardens of Aranjuez, and who had patronized naturalists and physicians throughout his life. Botanical knowledge wasn't a secondary whim for him, it was an instrument of power. And it is precisely that last word that opens the interpretation that historians of science have been developing for the last 50 years, especially sustained since the work of the Mexican historian José María López Piñero and the researchers of the Spanish Higher Council for Scientific Research. What Hernández's manuscripts contained was, in 16th century terms, strategic intelligence. Spain knew that other European powers, France, England, and the Netherlands, coveted control of the New World. The wealth of the Americas that Spain monopolized was not only the gold and silver that filled the galleons. It was also biological wealth, plants that could cure diseases, crops that could feed armies, pigments, resins, dyes, and poisons that had commercial and military value. Publishing Hernández's 16 volumes meant handing England, France, and the Netherlands a complete manual of the medicinal and agricultural resources of the territories that Spain controlled. Imagine what that manual would have meant to a pharmacist in Lyon in 1580, or to a merchant in Amsterdam, or to a physician at the court of Queen Elizabeth I, who in those same years was exploring the coasts of North America looking for exactly the kind of information that Philip II had locked away at El Escorial. From that perspective, Philip II's silence was a strategically coherent decision. It was not ignorance or contempt for knowledge. It was precisely the opposite. It was the recognition that Hernández's knowledge was so valuable that it could not be shared. But the consequences of that decision were devastating in a way that Philip II probably did not foresee, or that he foreseen and chose to ignore. The first consequence was medical. Europe continued to treat diseases with the plants described by Galen and Avicenna, while a catalog of 3,000 American species existed whose active ingredients could have radically expanded the available therapeutic arsenal. The epidemics that ravaged Europe in the 16th and 17th centuries, American syphilis, brought back by Columbus's sailors, the bubonic plague, and intermittent fevers, were treated with remedies that Hernández's manuscripts could have complemented. How many lives a timely publication would have saved is impossible to calculate. But the problem wasn't just one of speed, it was one of permanence. The second consequence was the one no one anticipated, and it was the most irreparable. On the night of June 10, 1671, a fire broke out in the monastery of El Escorial. The exact causes were never precisely determined. The fire started in the church tower and spread through the library with a speed that the friars who tried to extinguish it described as supernatural. Books, manuscripts, and state documents burned. Part of the natural history collection that Philip II had assembled over decades was consumed by the flames, and the original 16 volumes of Francisco Hernández's work were lost in the fire. Not all the manuscripts. Not absolutely. There were partial copies that had left El Escorial before the fire. Recchi's reduction, which had circulated in manuscript versions and was finally published in Rome in 1615, almost 40 years after Hernández's death. There was the edition that the Jesuits in Mexico City had prepared in 1651, based on local copies of some of the manuscripts Hernández had left in New Spain. There were fragments and quotations in the works of other naturalists who had had temporary access to the originals before the fire. But the complete text, with its 2,000 illustrations, with its intact cultural contexts, with the annotations of the Nahua informants, with Hernández's comments on the difference between medicinal and ritual use, with the complete dosages, with the warnings about toxicity, with the indications on harvesting season and method of preparation, that text no longer existed anywhere in the world. What we had was a mosaic of fragments, enough to know that something enormous had existed, not enough to reconstruct it. The historian Germán Somolinos d'Ardois, who dedicated decades of his life to gathering the scattered pieces of Hernández's work in the archives of the Institute of the History of Medicine at the National Autonomous University of Mexico, wrote in the 1960s a sentence that summarizes the tragedy with a precision that still hurts. Hernández documented the medical knowledge of an entire continent. Philip II kept it. Fire destroyed it. And no one in Europe realized what they had lost, because no one in Europe ever fully understood what existed. It is possible that among the plants Hernández cataloged, plants that were not rigorously documented again until the 20th century, or that have not yet been studied with the necessary rigor, there exist active compounds against diseases that remain incurable today. This is not a certainty, but a statistical probability. Out of 3,000 plants, given the level of biological activity of the vegetation in the American tropical forest, and considering the level of empirical knowledge the ticitl had accumulated over millennia, the probability that this entire pharmacological arsenal would turn out to be pharmacologically inert is so low as to be mathematically impossible to maintain. What was lost in the fire at El Escorial was not just the knowledge of Francisco Hernández. It was the knowledge of entire generations of Nahua physicians whose only written record in a European language consisted of those 16 volumes. The pre-Hispanic medical codices that could have complemented them had been burned decades earlier by Friar Diego de Landa and other missionaries convinced they were the work of the devil. The Cruz Badiano Codex survived because it traveled to Europe as a diplomatic gift. Bernardino de Sahagun's Florentine Codex survived because someone hid it well. But most of the medical and botanical texts of the Mesoamerican world burned in the bonfires of evangelization before Hernández arrived to document what still remained. When the fire at El Escorial consumed Hernández's manuscripts on that June night in 1671, what was lost was not just science. It was the last working copy of a medical tradition that had taken 2 millennia to build, that had survived the conquest, that had found in Hernández someone capable of transcribing it into a language the world could have understood. and that burned because a king had decided it was too valuable to share, and that time had caught up with it before anyone could change their mind. What researchers who have spent decades piecing together the scattered fragments of Hernández's work have been uncovering, piece by piece, has the structure of an archaeological excavation. Each fragment that appears confirms the magnitude of what is missing. The edition that the Jesuits of Mexico City published in 1651 under the title Nova Plantarum, Animalium et Mineralium Mexicanorum Historia, was not an honest edition. It was, at best, an amalgam. The Jesuits had worked from incomplete copies of the manuscripts that Hernández had left in New Spain, supplemented by Requi's summary and with additions from later authors that the editors did not always clearly distinguish from the original text. The result was a useful book, undoubtedly, and for 2 centuries it was the main reference on American medical botany in Europe. But it was also a book tainted by omissions, interpolations, and simplifications that no reader could identify without access to the original, which had burned at El Escorial 20 years after its publication. What researchers began to discover in the 19th century, when the history of science became a rigorous academic discipline, was evidence of what had been lost, revealed through what remained. The National Library of Spain holds fragments of correspondence between Hernández and Philip II that describe plants whose names do not appear in any of the published versions. The Archive of the Indies in Seville contains administrative references to the original volumes that mention entire sections on agricultural techniques, water management, and Nahua botanical classification systems, none of which are found in any of the surviving printed versions. The Vatican Apostolic Library holds a partial manuscript copy of the Requi Reduction, containing passages on plants from southern New Spain that do not appear in the 1615 Roman edition. Each of those fragments is a broken window into something that can no longer be fully reconstructed. The historian and physician Germán Somolinos d'Ardois, born in Spain and living in Mexico since the Civil War, spent the second half of the 20th century attempting to piece together these fragmented fragments. His critical edition of the complete works of Hernández, published in several volumes by the National Autonomous University of Mexico between the 1950s and 1980s, is the most comprehensive philological work on the Toledo-born physician's oeuvre. Somolinos gathered fragments from 7 countries, compared versions, identified interpolations, and reconstructed sequences. The result is a monument to scholarly patience. It is also tangible proof that what exists is, at best, only 30 to 40% of what Hernández originally documented. Between 60 and 70% of the knowledge that Hernández transcribed from the Nahua ticitl no longer exists in any recoverable format. That number requires you to stop for a moment. Consider what this means in pharmacological terms. Of the more than 3,000 plants that Hernández catalogued, only about 900 appear with sufficiently complete descriptions in the surviving versions. The other 2,000 or so are present, at best, as a Nahuatl name without a description, or as an illustration without text, or as a reference in administrative correspondence without details of use. For most of these plants, the knowledge that Nahua healers had taken 2,000 years to accumulate about their therapeutic action no longer exists in any accessible historical source. What 21st century plant pharmacology researchers are largely doing is independently reconstructing, from scratch, using gas chromatography, nuclear magnetic resonance, and computational models of biological activity, what a doctor from Toledo and a group of Nahua ticitl already knew in the year 1575. Over the past 40 years, the Institute of Chemistry at the National Autonomous University of Mexico has published a series of studies on Mexican medicinal plants that appear in the surviving fragments of Hernández's work. The results systematically confirm what the Nahua informants had described to him. Toloache, which botanists call Datura stramonium, and which Hernández described as both poison and remedy at the same time, in doses that only the experienced physician knows how to determine, contains alkaloids from the nightshade group, atropine, scopolamine, hyoscyamine, which modern pharmacology uses in anesthesiology, in the treatment of cardiac arrhythmias, and in the control of motion sickness. The distinction between poison and remedy that the ticitl, traditional healers, taught Hernández is precisely what modern toxicology calls the dose-response relationship. The same molecule kills in high doses and cures in low doses. That's not magic, it's biochemistry. The chicalote, which we mentioned at the beginning of this story, and which reappears here because the story warrants it, is one of the best documented cases of modern validation of a use described by Hernández. A study published in 2012 in the Journal of Ethnopharmacology by researchers from the National Autonomous University of Mexico and the University of Geneva demonstrated that the alkaloids of the chicalote, berberine, sanguinarine, and copticine, have direct inhibitory activity against Plasmodium falciparum at concentrations that would be clinically relevant. The study explicitly cites Hernández's description as the starting point of the research. 5 centuries separate empirical observation from molecular confirmation. 5 centuries that could have been decades if Philip II had published the manuscripts in time. Copalchi, whose bark the ticitl people had described to Hernández as regulating excessive thirst and frequent urination, diabetes, though not by name, has been the subject of active clinical research since the 1990s. A clinical trial conducted in Germany and published in the journal Phytomedicine documented that standardized extracts of copalchi bark reduce fasting blood glucose in patients with type 2 diabetes with an efficacy statistically comparable to metformin, the most prescribed hypoglycemic drug in the world. Researchers at the National Institute of Public Health in Mexico have identified the responsible compounds, prenolated coumarins with a mechanism of action that inhibits intestinal alpha-glucosidases, slowing the absorption of dietary sugars. This is the exact mechanism the ticitl could not describe in those terms, but whose effect they had observed and documented well enough for Hernández to accurately record it 5 centuries before biochemistry had the vocabulary to explain it. The problem is that those are the plants that appear in the fragments that survived the fire. What about the 2/3 that didn't survive? Here, modern research faces a fascinating paradox. On the one hand, ethnobotany and pharmacognosy have made enormous strides in the last 30 years in the study of medicinal plants in Mexico and the Andean countries. On the other hand, the systematic destruction of traditional knowledge systems, first by colonization, then by forced modernization, then by agricultural industrialization, then by cultural globalization, has left researchers in a situation where the knowledge that could guide their research is disappearing faster than it can be documented. Ethnobotany is the discipline that attempts to reconstruct what was lost with Hernández. It works with living informants, healers, herbalists, traditional doctors, to document the current uses of medicinal plants before the knowledge dies with its bearers. The problem is that this knowledge has been under pressure for 500 years. First, the Inquisition persecuted it as witchcraft. Then, university medicine dismissed it as superstition. Then, the pharmaceutical industry ignored it as irrelevant. Then, the younger generations who migrated to the cities stopped learning it because it was deemed useless in urban life. What remains in the herb markets of Mexico City, in the Sonora market, in La Merced market, in the Tlacolula market in Oaxaca, is valuable, incomplete, and disappearing in real time. A 70-year-old herbalist who knows exactly which moon phase quachilalade is harvested on and which other plant it's combined with for liver ailments carries in her mind information that isn't written down anywhere and that will die with her if no one sits down to listen to her first. What Philip II locked away in El Escorial and what fire destroyed was, in part, the equivalent of all that oral wisdom transcribed and systematized. A single historical opportunity to transform into a permanent text what otherwise lives only in the memories of individuals. That opportunity was lost. And now, 5 centuries later, the same race against time is being repeated, only this time without the possibility of recovering what has already disappeared in the interim. Therein lies the true anger of this story. Not in the fire. Fires are accidents. Not in Recky's decision to summarize rather than transcribe. Recky was a man of his time doing what he knew how to do. The true anger lies in the 44 years that passed between the arrival of the manuscripts at El Escorial and the fire that destroyed them. 44 years in which it would have been technically possible to publish them, in which other monarchs with other priorities could have done so. in which knowledge of the Nahua ticitl could have entered the mainstream of European medical science 2 centuries ahead of the process that finally began in a fragmented and haphazard way in the 19th century. 44 years of silence over a strategic decision that protected Spain's competitive advantage for a generation and cost the world 2 millennia of accumulated medical knowledge. However, the story has a post-fire territory that is less known and deserves attention because in that territory lie the seeds of what can still be recovered. The Jesuit Juan de Esteinefer, working in New Spain in the late 17th and early 18th centuries, produced a practical medical manual titled Florilegio Medicinal, which drew on local medical traditions and circulated widely among missionaries and folk healers throughout the colony. Esteinefer did not have access to Hernández's original manuscripts, but he did have access to the healers and traditional doctors who practiced what Hernández had documented. His book, reprinted multiple times throughout the 18th century and preserved in the archives of several convents in New Spain, contains hundreds of preparations that remarkably coincide with the surviving fragments of Hernández's work. The botanical expedition of Martín de Sese and José Mariano Mocinho to New Spain, undertaken between 1787 and 1803 at the behest of King Charles III, was in some ways a belated attempt to do what Philip II had begun, to systematically document the medicinal flora of the American territories. Sese and Mocinho produced a remarkable work, partly preserved in the Royal Botanical Garden of Madrid and partly in other European archives, which recovered the names and uses of many of the plants that Hernández had catalogued and which, in the intervening 2 centuries, had survived in folk practice but had disappeared from academic texts. The Royal Botanical Garden of Madrid, founded in its current form in 1755 by Ferdinand VI and moved to its present location by Charles III in 1781, preserves in its historical collections herbaria and manuscripts that include material related to the work of Hernández and to the botanical expeditions of the 18th century. The work of researchers from the Spanish National Research Council, CSIC, who have studied these collections in recent decades, has produced publications that are slowly reconstructing the map of what was lost and what survived. But the most active and significant recovery is not happening in Madrid's archives or university libraries. It is happening in the fields and markets. Contemporary ethnobotany in Mexico is among the most active in the world. The Institute of Biology at the National Autonomous University of Mexico, UNAM, the Center for Scientific Research of Yucatan, CSIC, the Interdisciplinary Research Center for Regional Integral Development, CIRES, of the National Polytechnic Institute, IPN, the Autonomous University of Chapingo, and the University of Veracruz. All these institutions have active programs documenting traditional medicinal plants, working in collaboration with indigenous and peasant communities throughout the country. The UNAM's medicinal plant database now contains information on more than 3,600 species with documented medicinal uses in Mexico, more than the 3,000 identified by Hernández, because 20th and 21st century research has compiled what the 16th century could not systematize. But there is a fundamental difference between what Hernández was doing and what many modern projects do. Hernández didn't just record the names of plants, he recorded systems. He recorded the combination of plants in compound preparations. He recorded specific clinical conditions with their observable symptoms. He recorded differentiated dosages. He recorded contraindications. He recorded the cultural context that made the plant part of a coherent medical system, not just a loose ingredient. Modern pharmacology tends to isolate the active ingredient, to extract the pure compound, test it in cells and animals, scale it up in clinical trials, and turn it into a pill. This process has enormous value and has produced genuinely effective medicines. But it loses something that Hernández's manuscripts captured with an intuition that 21st century science is only now beginning to recognize. That medicinal plants often work because several of their compounds act synergistically, and that isolating the individual active ingredient sometimes destroys precisely the action that made the whole plant effective. A concrete example: the copalchi bark, whose hypoglycemic activity we mentioned earlier. Studies that isolated prenulated coumarins as responsible for the effect found that the aqueous extract of the whole bark, the preparation used by the ticitl and documented by Hernández, is more effective than the equivalent in pure coumarins. The reason is that the bark also contains compounds that modulate the intestinal absorption of coumarins, making the effect more sustained and less abrupt. The ticitl didn't know this in biochemical terms, but they knew it in practical terms. They knew that the whole bark worked better than a concentrated extract, and they described it to Hernández. Hernández recorded it, and 4 centuries later, an analytical chemistry laboratory confirmed that they were right. That is the conversation that Philip II interrupted with his silence, and that the fire at El Escorial finally severed. And it is the conversation that, fragment by fragment, institution by institution, healer by researcher, is beginning anew. If these stories grab you, subscribe to the channel, because the next one is at least as disturbing, and it also involves knowledge that someone decided the world didn't need to know. The good news, and there is good news, however uncomfortable it may be to celebrate, is that the knowledge Hernández documented did not disappear entirely. It never completely disappeared. It survived where knowledge that power systems try to suppress always survives, in the everyday practices of people who were not powerful enough to be threatened and who had no reason to justify what they knew to anyone. The herbalists at the Tlacalula market in the central valleys of Oaxaca, who every Sunday unfurl their blankets laden with medicinal plants gathered from the hills of the Sierra Madre del Sur, are practicing an unbroken tradition with over 2 millennia of historical depth. They don't read Hernández. They don't need to. They are the wellspring from which Hernández drew, and that wellspring did not run dry with the burning of El Escorial. In the backyards of rural homes in Puebla, Tlaxcala, Oaxaca, Guerrero, and Veracruz, many of the plants Hernández cataloged still grow today, not because anyone consciously preserves them as botanical heritage, though some do, but because they are useful, because they have healing properties, because grandmothers cultivate them because their mothers, grandmothers, and great-grandmothers cultivated them. The chain wasn't broken. The conquest bent it. Evangelization strained it. Modernization stretched it until it was almost invisible. But it didn't break. The Plant Genetic Resources Center of the International Maize and Wheat Improvement Center, CIMMYT, based in Texcoco, maintains in its germplasm bank varieties of maize, squash, and beans that include genetic material dating back to the varieties Hernández saw cultivated in the milpas of the 16th century. The seed bank of Mexico's National System of Plant Genetic Resources for Food and Agriculture contains more than 23,000 accessions of cultivated plants, many of them traditional varieties that have not been genetically modified and that maintain the nutritional and phytochemical profiles of the varieties selected by Nahua, Mixtec, Zapotec, and Otomi farmers over millennia. In Spain, the Royal Botanical Garden of Madrid cultivates specimens of several of the species described by Hernández in its living collections, species that arrived in Europe during the 16th and 17th centuries. Some of these, tomatoes, cacao, avocados, chili peppers, vanilla, so radically transformed the European diet that it is difficult to imagine Spanish, Italian, or French cuisine without them today. But others, the medicinal plants that had less immediate commercial value, arrived in Europe in a fragmented way and with poorly understood uses, remaining for centuries on the margins of academic pharmacology. Many of these are being rediscovered today. The University of Granada has one of the most active ethnobotanical and phytochemical research groups in Spain, and part of its work focuses on American plants that arrived in Andalusia through colonial trade routes and became integrated into the folk medicine of rural communities in southern Spain without anyone documenting how or when. This silent integration, the American plant that ended up growing in an Andalusian garden because someone brought it, planted it, and discovered its usefulness, is itself a chapter in Hernández's story that has yet to be fully written. For those who wish to enter this world from their own kitchen or garden, there are specific and accessible paths. The seeds of many of the plants that appear in the surviving fragments of Hernández's work are available in traditional seed markets operating in Mexico, Guatemala, Peru, Bolivia, and Ecuador. Native seed cooperatives working with indigenous communities in Oaxaca, Chiapas, the Bolivian Andes, and the Peruvian highlands distribute plant material certified as genetically modified and with historical traceability that, in some cases, dates back to documented pre-Columbian varieties. Epizode, which grows wild in almost any soil without requiring care, is perhaps the most accessible plant in the region of Hernández for home cultivation. Its anti-parasitic properties have been documented since the 16th century and confirmed by modern chemistry. The precautions are clear. In high doses, Escorial, the compound that gives it its anti-parasitic activity, is toxic, especially to pregnant women, and should not be consumed in excessive amounts for prolonged periods. But in the quantities used as a seasoning in beans, mole, or tamales, as used by the Nahua farmers whom Hernández visited, it is perfectly safe and, in addition to flavor, provides antimicrobial properties that are not irrelevant in food preparation. Quatchulalate, which botanists call Amphipterygium adstringens, and whose bark appears repeatedly in the writings of Hernández as a treatment for stomach and liver ailments, is available in almost every herbalist shop in Mexico and in a growing number of natural product stores in Spain, Argentina, and Colombia. Clinical studies conducted at the National Autonomous University of Mexico have documented confirmed anti-ulcer activity. Precautions are also clear. There is insufficient evidence regarding its safety during pregnancy and breastfeeding, and it should be avoided by people with severe liver disease without medical supervision. Capalchi, which we discussed earlier, remains part of the traditional medicine of the Zapotec communities of the Isthmus of Tehuantepec and the Nahua-speaking communities of the Sierra Norte of Puebla. Standardized products based on its extracts are available in some pharmacies specializing in herbal medicine in Mexico and Germany. The main precaution is that it should not be used simultaneously with prescription hypoglycemic medications without medical supervision, because the combination can cause severe hypoglycemia. There's something I want you to notice in all of this. The path back to what Hernández documented doesn't lead through museums or the archives of El Escorial or university critical editions. It leads through Sunday markets. It leads through grandmothers' backyards. It leads through neighborhood herbalists. It leads through seed cooperatives that are doing exactly what should have been done continuously since the 16th century, keeping knowledge alive in practice, not just on paper. It also involves science, which is taking seriously what for centuries was dismissed as superstition. The number of studies published in high-impact journals on Mexican medicinal plants has increased more than eightfold between 2000 and 2025. Publications by researchers from the National Autonomous University of Mexico, the National Polytechnic Institute, the Center for Research and Advanced Studies of the National Polytechnic Institute, the University of Veracruz, and the Metropolitan Autonomous University on the biological activity of plants that appear in the Hernandino fragments are now part of the international scientific literature, referenced in the same journals where groups from Harvard or Oxford publish. It's a slow return, slower than it should be, with an artificially low starting point due to 5 centuries of silence, suppression, and fire. But it is a real return. Subscribe to this channel. We open a new chapter of the Nature Archive every week, and there's always something waiting for someone to dare to look at it head-on. In 1577, when Francisco Hernández delivered his 16 volumes to Philip II at El Escorial, he had been away from Spain for 7 years. 7 years wandering fields, markets, and hospitals with a notebook that gradually filled with knowledge unmatched in any European library. He was over 60 years old. He was ill. He would die 4 years later, in 1587, without ever seeing a complete version of his work published. What he couldn't see from that final silence was that the knowledge he had transcribed didn't need his book to survive. It had survived for 2 millennia without any book. It survived the conquerors, the missionaries, the royal decrees, and fire. It survived because plants keep growing even though no one names them in Latin, and because there are people who know what they're doing even though they've never read Galen, Hernández, or anyone else. The 16 volumes burned. The knowledge they contained continues to be sown in the fields of Oaxaca every spring.